Hi, I'm Bob. Welcome to the 5 Minute Econometrics program. This is an econometrics tutorial for basic econometric concepts and estimation methods. Today, we will discuss how to interpret the estimated coefficient when the outcome variable and the explanatory variable of interest take the level form or the logarithmic form. We often see 4 different combinations of the functional forms. I will show you each case with examples. The first is the log-log form. The explanatory variable of interest and the outcome variable are both in logarithmic form. Here, the logarithm is the natural logarithm. We can prove that the estimated coefficient beta 1 hat is the percentage change in the outcome variable as the explanatory variable increases by 1%. The derivative of the natural logarithm is as follows. So we can write delta log y hat as delta y hat over y hat, and delta log x1 as delta x1 over x1. Then, using the definition of the percentage change, we can write the percentage change in y hat equals beta 1 hat times the percentage change in x1. If x1 increases by 1%, then y hat changes by beta 1 hat percent. Beta 1 hat is also known as the elasticity. Here is an example of the log-log form regression. You can download the dataset from the link below. It is a dataset in the textbook Introductory Econometrics, a modern approach by Professor Jeffrey Woodridge. We regress the log price of the house on the log of the pollution measure and the number of rooms. The estimate for the log pollution is minus 0.718. We use the log-log form interpretation. It means when the pollution increases by 1%, the price falls by 0.718% after holding rooms fixed. Next, let's look at the log-level form. We can prove that the estimated coefficient multiplied by 100 is the percentage change in the outcome variable when the explanatory variable increases by 1 unit. The proof uses the Taylor expansion. When x is small, log 1 plus x is approximately equal to x. The estimated coefficient multiplied by 100 is the percentage change in the outcome variable when the explanatory variable increases by 1 unit. Using the same regression result, we find the estimate for the variable rooms is 0.306. We use the log-level form interpretation. It means when rooms increase by 1, the price increases by approximately 30.6%, which is 100 times the estimate of 0.306. The third form is our most familiar level-level form. As the explanatory variable increases by 1 unit, the outcome variable changes by beta 1 hat unit. Let's use the job training dataset. The outcome variable is hours of training per employee. It is in level form. There were 3 explanatory variables in the model. 2 of them are in level form. The first is the annual average employee salary. The second is a dummy variable equal to 1 if the firm received a job training grant. The estimated coefficient of 0.0003 means the hours of training per employee increase by 0.0003 hours as the average salary increases by $1. In other words, if the annual employee salary increases by $1,000, the hours of training increase by 0.3 hours per employee. The estimate for grant is 34.3, which means firms that received a grant trained each worker on average 34.3 hours more, holding the other variables in the model fixed. The fourth form is the level log form. Using the derivative of the natural logarithm, we can show that the outcome variable changes by beta 2 hat divided by 100 units as the explanatory variable increases by 1%. In other words, if the explanatory variable doubles, that is, increases by 100%, then the outcome variable changes by beta 2 hat units. In this regression, the third explanatory variable is in the log form. It is the log of the number of employees. It is a measure of the size of the company. The estimate is minus 6.02. This means that if the number of employees increases by 1%, the company trains its workers about 6 divided by 100, that is 0.06 hours less per employee. In other words, if a firm is 10% larger, it trains its workers about 0.6 hours less per employee. Thank you so much for watching this video. See you soon on the next topic. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.